Hi, welcome back to part 3 of Kalman Filter intuition videos. This will be the final part of the series. In this video, we are gonna get into the equation or the actual algorithm itself, and I'll try to point out the different parameters in the equation and hope you get some intuition from that. Okay. So overall, this is the algorithm in one simple snapshot. So we have the system. Say this is this boundary which I have kept. So this is the Kalman filter algorithm, which is trying to predict and update. So this is the outside system where every time we pass in some information to the algorithm and we try to get an output from the algorithm. So what is happening is the input can come at different time. It doesn't have to be coming into the system, coming from the system to the algorithm at regular interval. It can be at different moment of time. And the output is something which gets updated every time we get a new measurement. So if we don't have a new measurement, the output kind of remains what is that, like the prediction. So okay, it goes like this. Every time we try to predict, what we are saying is we are trying to estimate what's the new state of our system. So when we say the new state of a system, the state could be anything. Let's say it could be the heart rate, or else it could be the position of the car, or the temperature of say some device which we are trying to use to measure something. So the state could be multiple things. It could be like velocity and the xy coordinates, the yaw, the pitch, and anything it could be. It is something which is generic, and Kalman filter can handle that. So new uncertainty. Let's try to understand what do we mean by uncertainty. Uncertainty is say maybe you can say the opposite of confidence. How much we are not so sure about our prediction which we are making. So every time we are going to state that, okay, this is what your output will be, we need to know that how much confident we are about that. So here this is like the opposite of confidence. Maybe saying, okay, when we say that this is what the value is, but I am this much uncertain about it. So you may get the other words like say covariance, things like that as well. I'm not gonna go too much deep into that. Maybe I would maybe based on the comments and feedbacks, I may do a separate video. So the next step is, once we have some prediction about our state and the uncertainty of our information, we do an update based on what we get as a new measurement. So when we are saying that we are going to do an update, what it means is first we have to calculate how much the new measurement is deviating from our current state. So when we say input, it is the new state information which our measuring device or sensors are providing about the system. So we try to compare the new information with what we already have and try to see the delta, and that becomes our error. And the next step is to calculate the Kalman gain. This is something which we explained in the previous video, which is the weight factor which we said. This decides on which side the measurement estimate has to shift to. So given that, like say if the input measurement seems to be too noisy, Kalman gain will give more weightage towards the prediction which we already have. And if we see that, okay, we are not so certain about what we already have and maybe the new measurement seems to be better, the Kalman gain will kind of multiply that factor and tries to put more importance to the new measurement which we are getting. And the fifth point and sixth point are very, this step is similar to what we are having, but we are saying using the new Kalman gain and basically using the new information which we are getting, we are trying to update the state on this step. So, and again, when we say we are updating the state, it is a new estimate which we are doing. So there again has to be change in the uncertainty which we were having before. Maybe as we get more measurements, we might become more certain about what we can estimate. More data, better estimation. Okay. So yeah, actually what happens is this is a loop. I forgot to explain this part where this keeps continuing as and when you're gonna get the information, and this again input could be from multiple sources, and you'd repeat the same set of steps. Okay, the prediction part. We said first we are trying to do an estimation or update the state. So x is the previous state, x dash is the new state, and here what this a, b, and these information are nothing but a set of matrices which are helpful to do the transformation for us. So that those things are not something which is you need to worry too much. So the fundamental concept is, or to get an intuition, the main thing is we are trying to say predict the new state from the using the previous state value. And here the other part is u is nothing but say it could be a control factor. When we say control factor, it is the factor which we have some more information about our system. It could be say the acceleration of our system, or maybe other information about our system which is also going to drive our prediction. So W is the noise of the system. Usually these factors gets ignored, and maybe it's just these information which we get, and maybe just the noise also. Yeah. So how do we get the unpredictability or the covariance matrix here? So I think to better explain this, maybe it's easier if I am gonna highlight what is important and what is something which is more significant in trying to understand or get the intuition. So again, here if you see, the prediction is all dependent upon what was the information previous to our prediction. And maybe I should have put this as p dash, but yeah, so this is the new p, new uncertainty which is dependent on what is the previous uncertainty. And this A matrix is the same as the A matrix which you would have used. So there is this other one more parameter which you might notice here, which is the Q. So this is nothing but you can say this is a minimum amount of information, or minimum amount of uncertainty we are specifying in our prediction, because it shouldn't become where the system is predicting so much as it goes. Maybe at certain point it might get stuck with its own prediction, and it might start to ignore the new measurements. To avoid such scenario, we always add some minimum uncertainty to the prediction, because intuitively if you try to understand, if this is 0, whatever the prediction which we are already having, that's all the system is going to output. It becomes invariant to the new information it is going to get. So to avoid that, we always add some level of saying that okay, you don't completely rely on prediction no matter how much certain you become about your prediction. So always have some unpredictability or uncertainty on our prediction. So maybe I would see this as trying to be humble about the algorithm itself, where like the algorithm always tries to be humble in saying that okay, I'm ready to learn if you give me enough new evidence. So that's the part of prediction. And if we go on to the next step of update, I'm gonna again update the equation itself, and what you're going to see here is, this is the part where we are trying to measure the error. So z is nothing but the representation of the input which we are getting. This is the input measurement, and x dash is the prediction which we had previous to the input which we received. So all we are trying to do here is we are trying to find the difference, and that becomes our error, and that I'm saying that as y. And then say this is what the Kalman gain is, and this is the important part where all we are trying to do is we're trying to see, this is the balancing act which we were discussing, and in the diagram, if you remember, the it is using the error which it's not using the error, it is using the uncertainty in our prediction system, in our prediction which was calculated, and comparing that with the uncertainty which is there in the measurement itself. So this usually might be a constant, or this might be given as part of the measuring device which you are using. So you are comparing that measuring device's uncertainty with the uncertainty of the prediction which we are making. So say if the uncertainty of the device is more, we rely more on the prediction which we are making. And if the prediction's uncertainty is a lot, we rely more on the measurements which we are getting. So that's the ratio which we are calculating, and that's what the Kalman gain or the weight is for us. So once we have this with us, once we have the error and how much reliant our prediction or measurement is, once we have this information, now we are ready to calculate our new state and the uncertainty of our prediction. So what it's going to do is, again, this is nothing but the state which we already have estimated, plus the Kalman gains multiplication with the difference in error and the function which we have here. So this is fundamentally what we are seeing, right, where we are trying to multiply the Kalman gain with the factor of deviation which exists. This is the imbalance which we are seeing. So based on the imbalance, we are trying to multiply the imbalance and adding that missing information to our state. So on the next part of uncertainty, we are using the uncertainty which was there already, and again the Kalman gain or the weight comes into picture again. By the way, the H is again another matrix which is being used. It's used for transformation and doing this linearizing things. I would say, like, don't worry about that much, but because that's not necessary to get the intuition. And I is just an identity matrix for you to do this calculation. So yeah, this is that's it. Like, and this is all Kalman filter is all about, where you try to predict, you try to update as you get the new information. So I hope you got good intuition about this. Please let me know how this video helped you, and maybe I will try to improve. And to get more information, I'll really highly recommend this particular link. This is where I learned what Kalman filter is about, and I've done a project also. You can look at my GitHub and try to go through the code. It's done using C++. Yeah, thank you. Bye.